Hey, it's Mr. Kingsbury here from Algebra 2. Our current unit is quadratics, and today I want to talk to you a little about converting between forms of a quadratic equation. Don't forget to put your period and the date on your notes here. Our essential question is, how do I convert between the standard and vertex forms of a quadratic equation? Now, the actual conversion itself is not difficult, and I'm going to show you how to do that. But before I do that, let's talk about what these forms actually look like. So there are two forms, standard and vertex, two forms of a quadratic equation. The first one would be standard form. Standard form is y equals ax squared plus bx plus c. You can certainly get the y-intercept out of it. That would be 0, the c value. And mostly the reason that it's really super important is you can use these values of a, b, and c to solve for x. This is the best one to solve from. We can factor this. We can use the quadratic formula. We can solve by completing the square, amongst other things we can do. So this is a great form for solving. The other form is called vertex form. And it looks like this. Y equals a times x minus c squared plus d. This one is really great for transformations. And that's because these letters each tell us stuff. Remember, C tells us how far the thing has been moved left or right. D tells us how far it's been moved up and down. And A tells us whether it's been stretched or compressed vertically. There's also another letter B, but we're not going to look at that. That one's horizontal stretches and compressions, but don't worry about that one. The other thing that's great about this, and this is why it's called the vertex form, is because you can find the vertex. And the vertex is simply the c value, the d value, which is really, really important. In a quadratic especially, the vertex is probably the most important point because it's the point where we either stop going down and move back up, or stop moving up and move back down. It's either the highest or the lowest, so it's a minimum or maximum. Very important. So being able to go from one to the other allows us to take one thing and the information that comes with it, translate to the other, and get that information. So we probably need to practice doing that a little bit. So let's start by going from vertex form to standard form. There are 3 steps. 1, expand the binomial. 2, distribute. And 3, combine the constants. Right now you're going, what? Why don't I give you an example or two to look at? So here's example 1. We're going to have the equation y equals 4 times x minus 2 squared minus 41. Step 1 says expand the binomial. Well, the binomial is this part right here in the parentheses. It's this 2-termed polynomial, and we're squaring it. That means we're multiplying it by itself. So, if you will, for a second, I'm going to grab a piece of scratch paper. Actually, you know what? I'll just do it off to the side. The thing is, the whole expanding thing, at this point, I don't know that I really need it as part of my conversion here. But I am going to need to be able to actually do the expansion. So I'm going to use the box method, right? So x minus 2 squared, side note, x minus 2 squared means x minus 2 times x minus 2. And one of the biggest mistakes people make is instead of recognizing that it means this, they go, okay, I'll just square the x and square the 2. I have x squared minus 4. Life is good. Let's go. That's not what it means. It means we're multiplying x minus 2 and x minus 2. And you should recall from your studies in Algebra 1 that when you do polynomial multiplication, when you're multiplying one polynomial by another polynomial, there are several methods you can use. The box method is one of the best. So you would need to do this, x and negative 2, x and negative 2, and then treat it like a multiplication chart, right? X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. So we get 4 terms, x squared minus 2x minus 2 more x's plus 4. And then we can combine our two like terms there. So we get x squared minus 4x plus 4. This is an aside. I don't need this as part of my official conversion. But I need the result because that's what goes next. So I started with y equals 4 times the quantity x minus 2 squared minus 41. When I expand the binomial then, I get y equals 4 times, and then this whole piece here, we just expanded it. So it's now become x squared minus 4x plus 4. And then outside is minus 41. Some of you are going to want to put a squared on here. No, we found the squared. We used the squared when we multiplied it by itself. So that's gone. What's important is to recognize that this whole thing is being multiplied by 4. That's why the 4 is out here. And in fact, that's step 2. Distribute this 4. So I get y equals, and then I distribute the 4. 4 times x squared is 4x squared. 4 times negative 4x is negative 16x. And 4 times positive 4 is positive 16. And don't forget we have a minus 41 there. And the last step is combine the constants. That would be this and this. So the y equals doesn't change, the 4x squared doesn't change, and the minus 16x does not change. What changes is I'm going to combine 16 and negative 41. And when I do that, I believe I get minus 25. And you will note that now I am in standard form. So that's what we were looking for. How about I do another one for you really quick? And then we'll see about going the other direction. So let me do some more notes here. Example 2. Let's see here. I'm not sure exactly. Well, let's do this one. Sorry, I have a number of them I can select from, and they all have different little bits and pieces that it might be nice to talk about. But I only have so much time, so we'll limit it to this. So we've got y equals negative 2 times x plus 6 squared plus 67. There you go. So step 1, if you remember, it's on my other page. I'm supposed to expand this. So I'm going to use my box method. We got x and 6 and x and 6. X times x is x squared. X times 6 is 6x. 6 times x is also 6x. And 6 times 6 is 36. So my 4 terms are x squared plus 6x plus 6 more x plus 36. And if I combine my two 6x's, I get x squared plus 12x plus 36. So y equals negative 2 times x plus 6 squared plus 67 will become y equals negative 2 times this, x squared plus 12x plus 36, and then plus 67 on the end. Then we distribute the 2 here, here, and here, and we get y equals negative 2x squared minus 24x minus 72 plus 67. And the last move is to combine the negative 72 and negative 67. So we get y equals negative 2x squared minus 24x. And we put these together, we get, I think, negative 5. And that's my standard form. Not too shabby. And honestly, that's the more difficult of the two, I think. It's also the more organic and the more straightforward. You notice that each step leads to the next step, so they just build off of each other. Going the other way, going from standard to vertex, is a little less organic. It's actually pretty simple, but the pieces aren't necessarily connected. They don't necessarily build off of each other. Instead, it's kind of you do one piece, and then you do another piece, and then you do another piece, and then you build all of the equation together. When you're going from standard to vertex form, what you're going to want to do is find the A, the C, and the D values. So to do that then requires a couple steps, and hopefully I can explain them pretty well. Let's see. So we need to find A, C, and D. And it turns out A is the same for both versions. So what we really need to do is find the C and the D. And I say C and D, and I feel bad. We sometimes use C and D. We sometimes use H and K. I feel like I should probably go back and change this to H and K. So I'm going to do that. My apologies. We will make this H and K. And the reason for that is if you use C and D in both of them, then you think the C's are the same and the D's are the same. They are not. That makes the vertex H, comma, K. Alrighty. Sorry for the confusion, guys. So, where was I going? There are, I want to say there's 3 steps. Yeah, there's 3 steps. So, step 1, find A. Step 2, find H. And you do that using the following formula. H equals the opposite of B over 2A. And then step 3, you find K by plugging in H. And right now you're going, I'm sorry, what? Let me explain. Here is an example, example 3. And we are going to convert from from standard form to vertex form. So let's use this one. Y equals 3x squared minus 12x plus 4. What I need to find are the values A, H, and K. Step 1 says find A. Well, that's really easy. The A here is the same as the A in the vertex form. So they will both be 3. So step 1, ridiculously easy. Step 2, we got to find H. And we're going to find H by using the opposite of B over 2A. So it seems like knowing what A, B, and C are, it might be helpful. A is my 3, B is negative 12, and C is 4. That will help us. So when I do this, H equals the opposite of B. B is negative 12. The opposite of that is positive 12. And 2A. A is 3. So that would be 2 times 3, which is 12 over 6, which is 2. So H is 2. And then lastly, we're going to find K by plugging in our H value. So what we will do is take Y equals 3x squared minus 12x plus 4. And I want to remind you that my H value and my K value, those are parts of an ordered pair. Those are the X and Y values of an ordered pair. So what I can do is to find specifically the K value, I put H in for X. H was 2. So this is 3 times 2 squared minus 12 times 2 plus 4. And honestly, if I really, really, really wanted, I could simply type all of that into the calculator. There's no solving. It's just PEMDAS. So let me show you right here. We've got 3 times 2 squared minus 12 times 2 plus 4. I hit enter and I get K is negative 8. And I think I'm going to adjust the 3 steps for a second. I knew there was 3 steps, but, well, maybe I won't. From here, then, we can build our equation, right? So our vertex equation was y equals a times x minus h squared plus k. So all I have to do is plug in my values. A is 3 times x minus h. H is 2 squared plus k. K is negative 8. So I'll put minus 8, and there's vertex form. Not too shabby. Let me do one more, and then the video will be done for you, and you can go about your business. I'm sorry the video is taking a little extra time. It happens. But I want to make sure you get all the information down. So, example 4. Let me throw it up here. And I'm going to make this one a little more challenging. I'm going to throw some extra negatives in here just because I want to show you that it's not that big a deal. And then let's just use some bigger numbers. So let's go with y equals negative 3x squared minus 24x minus 55. Looks like my a is negative 3, my b is negative 24, and my c is negative 55. And what I need to find is a, h, and k. And look, my a is negative 3, so I already have that one. Step 2, what is my h? Well, h will be the opposite of b over 2a. b is negative 24, so the opposite of that would be positive 24. And that's over 2 times my a value. My a is negative 3. 2 times negative 3 is negative 6. This gives me 24 over negative 6, which is negative 4. So my h value is negative 4. And then lastly, I can plug that into the equation and get k. So k will be equal to negative 3 times negative 4 squared minus 24 times negative 4 minus 55. And again, I can just type this right in the calculator. So let me do that. Negative 3 times negative 4 squared. I like to use the parentheses for the squared. Minus 24 times negative 4 minus 55. Enter. I got negative 7. So k equals negative 7. Now I got to do is type some stuff in. So my vertex form is y equals a times x minus h squared plus k. And I will now plug in my values. Y equals a is negative 3 times x minus h. That's h is negative 4 squared. And then it says plus k. K is negative 7. And I'm going to clean a couple things up here. The y in equals looks good. Negative 3 is good. X is good. But these two negatives, they form a positive. So I'm just going to clean that up a little bit. And instead of putting plus negative 7, I'm just going to put minus 7 like that. I apologize for all the crazy sounds going on in the background, but that's how you convert from one form to another. I will see you in class.